571 Logarithmic Functions. When we are working with logarithmic functions, a logarithm is literally just the exponent to which a specific base is raised to obtain a given value. The function that's a logarithmic function is the inverse of an exponential function. So when we do these, we're going to be working either clockwise or counterclockwise. So when we look at the first set of examples here, we're converting from exponential to logarithmic form. When we go from exponential to logarithmic, you want to think clockwise. That variable, or that exponent will become your answer, and your answer will become your number that is like your whole number. So the way that this works is you're going to have log in every answer. If we look at example 1, this 2 that's the exponent will switch places with the 81, but the 81 is going to become a whole number, and this 9 is going to become the base. So when we do this, it's going to be log 9 of 81 is equal to 2. It just means that your little 9 is raised to the second power to get the 81. For b, we have 3 raised to the third power is equal to 27. So we're going to write the word log. The big 3 is going to turn into our base. Let's write this a little better. And then that 3 as your exponent is going to change places with the 27. And then your 27 is going to be next as a whole number, then it's equal to 3. So log 3 of 27 is equal to 3. For c, we have x to the power of 0 is equal to 1, where x is not equal to 0. So this would just be log x of 1 is equal to 0. The exponent goes to the answer becomes the whole number, big number becomes the base. For d, we have 6 to the power of 0 is equal to 1, so that's log 6 of 1 is equal to 0. For e, we have 8 to the power of negative 2/3 is equal to 1/4. So this negative 2/3 is going to go to the answer. The 1/4 is going to come to the opposite side of the equal sign. That 8 is going to become a subscript of the 8. So log 8 of 1/4 is equal to negative 2/3. You're just rearranging your orders here and putting in that log. For f, we have 5 to the power of 3 over 2 is equal to 5 square root 5. So again, this 3 over 2 is going to switch places with the 5 square root 5. This big 5 will turn into your base or your subscript. So we have log 5 of 5 square root 5 is equal to 3 over 2. When we work from logarithmic form to exponential form, you're going backwards and you want to think counterclockwise. So you're going to drop that log. Your little subscript number is going to become your base raised to the power, that's your answer, and then your whole number that's on the left side of your equal sign will become your new answer. So for example A, we have log 10 of 10 is equal to 1, so we're going to drop the log, get rid of it. This 10 becomes a big 10. This 10 switches places with the 1, and that 1 becomes an exponent. So 10 to the power of 1 is equal to 10. For b, we have log 12 of 144 is equal to 2. So drop the log. We're going to have 12 to the power of 2 is equal to 144. These are all going to be true statements. So if you raise that 12 to the second power, you should be getting 144, which is true. For c, we have log 1/2 of 8 is equal to negative 3. So we're going to drop the log. We're going to have 1/2 to the power of negative 3 is equal to 8. For d, we have log 6 of 36 is equal to 2. So drop the log. So 6 to the power of 2 is equal to 36. E, we have log 2 of 2 is equal to 1. Drop the log. So 2 to the first power is equal to 2. For f, we have log 10 of 0.001 is equal to negative 3. Drop the log, so we have 10 to the power of negative 3 is equal to 0.001. With special logarithms, or special properties of logarithms, these are just used to evaluate these logs. So if you have something like log 5, it's the same exact thing as log 10 of 5. So whenever there's just that word log there without a base, that subscript number, it's automatically that subscript number is a 10. Okay, so if we look at example 3a, we're evaluating using mental math. So the way that we do this is we're going to say to ourselves with a, we have log 1,000. This, again, is an invisible 10 as the base. So it's really asking us 10 to what power is 1,000? Well, 10 to the third power is 1,000, so that answer would be 3. So this little exponent that's your question mark is your answer with these now. With b, we have log 4 of 1/4. So this is saying 4 to what power is 1/4? Well, 4 to the power of negative 1 is 1/4, so negative 1 is our answer for this one. For c, we have log 0.00001. So this is an invisible 10 for your base. So 10 to what power is 0.00001? Well, that's the same thing as saying 10 to what power is 1 over, this 1 is in the 100,000s place, so it's 1 over 100,000. From here, that would give you what? How many zeros do you have? 1, 2, 3, 4, 5. So that's 10 to the negative 5th power is equal to 0.00001. So negative 5 is our solution. For d, we have log 25 of 0.04. So again, this is 25 to what power is 0.04. This is the same thing as saying 4 over 100, which is 1 over 25. So 25 to what power is 1 over 25? That's 25 to the negative 1st power. So our answer for this one is that negative 1. For e, we have log 5 of 25. So this is asking you 5 to what power is 25? Well, 5 squared is 25. So our exponent there is the 2. Our answer is 2. For our next part, we are dealing with logarithmic functions. Your domain for these of y is equal to 2 to the power of x is all real numbers. You got to look at these graphs. So your domain is your x values. Your range, your domain of log 2 of x is also is going to be the x is greater than or x is less than. You literally have to graph these in order to find your domain and range. So if we look at the first example, we have f of x is equal to x to the power of, 3 to the power of x, where x is negative 2, negative 1, 0, 1, and 2. So this is going to be x is equal to negative 2, negative 1, 0, 1, and 2. We got to find for f of x, or y. 3 to the power of negative 2 is 1/9. 3 to the power of negative 1 is 1/3. 3 to the power of 0 is 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9. So taking the inverse of these, we're just switching them. So our x values are going to be 1/9, 1/3, 1, 3, and 9. Our y values are going to be negative 2, negative 1, 0, 1, and 2. So we go to graph these. Our first one, that x is negative 2, negative 1, 0, 1, and 2. We're going to have, first point is negative 2, 1/9, which is going to probably be about here. And then negative 1 1/3, so we're going a little bit up. 0 1 1 3 and 2 9. For our second function, we have 1/9 negative 2. So 1/9 negative 2 is about here. Then we have 1/3 negative 1, which is about here. Then 1 0, 1 3 1, and 9 2. So this is just going to go this way. For your domain here, look at the red line. Your domain of the red line, where are your x values? It doesn't cross the y-axis here, so your x values are greater than 0. It doesn't touch the x-axis either, so it's not going to be equal to that 0. It's going to be anything greater than 0. Your range for this one is all real numbers. So we're looking at the red part here. So all of this is what's important here. For example B, we have 0.8 to the power of x, and x is negative 3, 0, 1, 4, and 7. So if we do the original function, we have negative 3 as an x value, so 0.8 to the power of negative 3 is, we're going to round this to 1.95. 0.8 to the power of 0 is 1. 0.8 to the power of 1 is 0.8. 0.8 to the power of 4 is 0.41. And 0.8 to the power of 7 is 0.21. So if we graph these points, we are going to have negative 3, 1.95, which is about here. Then we have 0, 1, 1, 0.8, which is going to be up there. Then 4, 0.41, then 7, 0.21. So this does not look right. However, if we draw our line through it, there is a slight curve happening here, which would look like this. Now, we have to find the inverse of this. This line doesn't really matter. We're looking for the inverse of this and the domain of the inverse. So, inverse, we're just switching these around. Your function is going to become the log of 0.8 to the power of x. So that's log 0.8 of x. Okay, now we have our x values, which are going to be the 1.95 with negative 3 for our y, the 1 with the 0 for our y, the 0 and the 1. Oh, that was right. And then the 0.8, comma 1, and then 0.41, comma 4, and 0.21, comma 7. So if we go to graph these, the 1.95 negative 3 is going to be here. And then this is wrong. This should be here. So this should go this way. So let's redo this one before we get any further. So negative 3, 1.95 is here. So when we do this, our line should be curving this way. All right, so looking at the other points for our inverse, we have 1, 0, which is here. Then we have 0.81, so that's going to be about here. Then we have 4.14, so that's about here. And then 0.217, so that's going to be about here. So this one is curving this way. Let's do this the right way. We're going through these points this way. And then this one's not crossing the y-axis here, so look at your x values. Your x values are all to the right of that y-axis. So our domain is going to be x is greater than 0. Our range, of course, is just all real numbers. For our example C, we have 3/4 to the power of x. So 3/4 is the same thing as 0.75 if you want to do it that way. So the inverse of that would be log 0.75 of x. So we're going to plug those values in for x. We have 3/4 to the power of -2. So 0.75 to the power of -2 is 1.87 repeating. So that's 1.7 or 1.8. With the -1, we're going to switch that, be 4/3. So that's 1.3 repeating. We can just round that to 1.3. 3/4 to the power of 0 is 1. 1 or 3/4 to the power of 1 is 0.75. 3/4 to the power of 2 is 0.56. And 3/4 to the power of 3 is 0.42. Oops, 42, not 49. So if we take the inverse of this, switch the values, we can graph this right now as well, if you wanted to. If we do that, we have -2, 1.8, which is about here. Then we have -1, 1.3, so that's about here. 0, 1, 1, 0.75, then 1 or 2, 5.56, and 3.42. So we're going to have a line that curves this way but doesn't go past that x-axis. If we take the inverse of these points, so opposites, so we're switching our x and y values, we have 1.8, 2, 1.3, -1, 1, 0, 0.75, 1, 0.562, and 0.423. Let's go graph these. The positive 1.8, -2 is about here. Then we have 1.3, -1, 0, 1, or 1, 0. Then 0.751, 0.562, and then the 0.423. So this is just going to go this way. Again, it's not going to cross through or touch that y-axis. So your domain for this red line is x is greater than 0, and your range is all real numbers.